Hello everyone, welcome to this video. In this video, we are going to see Cayley theorem for group isomorphism, right? So what is this Cayley theorem and why do we need to study this Cayley theorem? So let's have a look here. So here you can see, to answer this question, let's see what is the question. The question that we have is, how do we prove the group of real numbers under addition? So this is one group, right? And the second group is the group of complex numbers under addition. So we have these two groups. One is real numbers under addition and one is complex numbers under addition. So how do we prove that both of these groups, they are isomorphic to each other? This is one thing. So that means we need to find a mapping such that it is 1 1, it is onto, it is order preserving, right? So in other words, we have this question that can we prove or disprove that the group of non-zero complex numbers under the operation of multiplication, this is one group, all non-zero complex numbers under multiplication. So we have excluded 0 from it. Why? Because we do not have the inverse of 0 under the operation of multiplication. That is why 0 is not included here, and that is why it forms a group, right? Another group is the group of complex numbers with absolute values of 1 under multiplication. So the operation here is multiplication. It consists of all the complex numbers whose magnitude, whose absolute value is 1. So we may denote the first group as the punctured plane. So whole of the complex plane excluding the number 0, which we can call by punctured plane. And the second one, the group of complex numbers with absolute value 1. So that would form the unit circle, because here the magnitude of each of the individual is just equal to 1, right? So therefore, under multiplication, both of them are they isomorphic to each other. Now for this also you need to find a mapping such that it is 1 1, it is onto, and it is operation preserving. So in some cases you are able to find such a mapping, in few cases you are not. So what do we do then, right? So we see sometimes it becomes difficult to prove or disprove that the two groups are isomorphic to each other, because we cannot just go on and search for a mapping which is both 1 1 onto and it is also operation preserving. So what do we do instead? So to our rescue, we have Cayley theorem for that. Now what is this Cayley theorem? Cayley theorem states that every group is isomorphic to the group of permutations. We know the group of permutations, that is very easy to study, right? So we just have to see different permutations of different elements present within the groups. This theorem states that every group could be expressed as group of permutations. So every group is isomorphic to group of permutations. So you see, this is a very powerful result. Now why is this theorem important? It is because it allows us to represent any abstract group. So we are given a group of any kind, we can express it in a concrete way by using permutations, correct? So basically this theorem tells us that abstract groups, they are not different from the permutation group. So this is the essence of this theorem. So in the next video we'll be looking at example where we can apply this Cayley theorem. So then you will see the power of this result. Well, that is it for this video. Thank you for watching.